Welcome everyone to another Seating Dynamics quick class. Today we'll be talking about durability and dynamic seating. My name is Michelle Lang. Let's jump in. So perhaps you're working with a client who has a history of equipment damage. They might have broken components of the seating system, the hardware that mounts the seating system to the frame, even the frame itself. And this might be due to very strong movements, movements that are repeated, movements that can be rather sudden or explosive, and some of the time could be sustained against this system. So dynamic seating absorbs these forces, not only addressing the needs of the client and their equipment, but also providing movement. Now, it's one thing to handle all that force without breaking, but to move while those forces are occurring requires a very durable dynamic seating component. So design becomes very important. How do we build in movement, force absorption and diffusion, but also keep the dynamic component from, well, exploding? We have to look at the travel, the amount of resistance, and the design of the component itself. So let's start with travel. And no, we're not talking about vacations, unfortunately. A dynamic component is designed to travel or move a certain degree and then return to a starting position. If a dynamic component reaches its full travel, it can't move any further, then client forces sometimes can be translated to the wheelchair frame. Well, how does that work? Well, let's look at this picture here. On this picture, we have an elastomer in the middle of this dynamic rocker back. And you can see these arrows are pointing to the metal above and below the elastomer. These should not touch. If the client is able to compress that fully and the metal surfaces are touching each other, then instead of the elastomer taking the hit, the forces from the client can actually be translated through this entire dynamic back hardware to the frame. We don't want that to happen. If this elastomer perhaps is much too firm for the client and doesn't move at all in response to their forces, then again, client forces could conceivably be translated to the frame. But if the dynamic component's kind of mid-travel, whether it's an elastomer, a spring, a hydraulic, then the forces are appropriately absorbed by the component. So here we have a static wheelchair. In the middle here, if there are unrelieved forces occurring here, the client can push against those static surfaces like the back canes, and this can lead to breakage. A dynamic back is designed to move, to absorb those forces. Now, if the resistance is too low, let's say an elastomer in this case that is too soft for this client, then the client may be able to completely compress this to the point that these two metal surfaces are contacting each other. And now we don't have any further force diffusion. Instead, force goes directly through this and can again lead to breakage. So it's important that the resistance is not too low. Further design considerations mean that we need to ensure the dynamic component itself is made of very durable materials to prevent that from breaking. Another design consideration that can help with durability is reducing the amount of parts. So if there's more parts, more screws and bolts to hold those together, this allows more movement between those parts, and that increases wear and tear. So on the left here, we have a dynamic component that has multiple bolts and holes going through various portions of the component to hold it all together. Now, as our client is moving within their wheelchair, there gets a little bit of wear and tear between the holes and the bolts or screws. And those become, instead of nice and round, tend to wear out and become an oval. You might even notice some aluminum dust, some silver dust on the back of the person's chair. This could indicate that there's movement happening between these various parts instead of movement where we want it to, at that elastomer or that spring or that hydraulic. So, what's the bottom line? Well, when recommending dynamic seating components, we have to keep in mind the durability of the component itself. When choosing resistance, it's important to ensure the client cannot move the component through the entire amount of available travel because this can translate forces from the client to the frame rather than that dynamic component. So we have to make sure we have the right level of resistance. We have some other quick classes that talk about determining resistance, so I'd refer you to those as well. But proper recommendation and configuration can make or literally break that outcome. If you have any questions about this or other courses that we have offered, please reach out to us. We're very happy to answer any questions, problem solve with you. And I hope to see you with another quick class very soon.